Hi everyone. I'm going to go through some of the questions you guys had on the homework. I want to talk about what the assignment was first. The assignment was the textbook problems, and I assigned 61 and 65. There's also originally 63 that was assigned. I'm going to go through this one because it's going to be part of a lecture that we're going to talk about. That lecture is going to be on center of gravity. So in this video, I'm going to talk about center of gravity in addition to this problem. The other assignment was page 18 to 21. The problems I'm going to go over are number 7 and number 2. Number 6 was a question that was asked about a lot, but it's very similar to number 65 in the textbook. And I'm actually going to go over number 65 because it's a little bit harder because it has friction. Okay, so I'm going to start with 63 right now. Okay, 63. So I guess to talk about center of gravity, you need to refer to your textbook on page 204. There's like a little paragraph, and it just talks about the equation. So to find the center of gravity of something that's not uniform, you're going to use the equation. This is x, which means the position. Sorry, I wrote center of mass. How do I erase? This is the position of the center of gravity. And the equation for this is x1 m1 plus x2 m2 over m1 plus m2. Again, this is in your textbook on page 204. Now, the AP test might have this, so it's important that you know this, and I don't think this is on the equation sheet. Okay, so we're going to go through 63. So let me look at the problem really quick for 63. 63 is right here. A 1 kilogram ball and a 2 kilogram ball are connected by a 1 meter long rigid massless rod. The rod is rotating clockwise about its center of gravity at 20 RPM. What's the torque? What torque will bring the balls to a halt in 5 seconds? Okay. So I'm going to draw a picture of what this looks like. Here is the massless rod. And this right here is 1 kilogram. And here, so this is number 63, by the way. And here is 2 kilograms. This is 1 meter. Okay, and this, by the way, is massless. So this has 0 mass. Okay, so when you think about center of gravity, you want to think about where can I hold this rod so it's balanced? Like if I put this on one finger, where would I have to put that finger so it's completely balanced? And if you actually held this, you would know the answer, but if you have good intuition, you would say it would be somewhere closer to the 2 kilogram rod, the 2 kilogram mass. So I'm going to find this location of that center of gravity using this equation. So to find this location of x1, that's the distance from the pivot. So you assign the pivot point. The pivot point that I'm going to assign is right here. And it's arbitrary, so it doesn't matter where you assign it, as long as you pick a location and just call it, that's where it is. Okay, so I could have picked it right here, I could have picked it anywhere, but this is where I'm going to pick it because I think it's easier. Okay, so x1 is the distance that this mass is from that pivot. So that is 0 because it's at that point. Mass 1 is 1 kilogram. x2, so I'll write this over here. x1 in this case is the distance between mass 1 and arbitrary pivot. And in this case, that's 0 meters. So x2 is a distance from this mass to that red pivot. And in that case, it's 1 meter, and that mass is 2 kilograms. And then for the denominator, you just add the two masses. So 1 kilogram plus 2 kilograms. So I have 2 over 3 meters. Okay, so that means this distance, let me change my color. This distance from here to here is 2/3 of a meter. So I like decimals, so I'm gonna write 0.67 meters. And this distance, that means is 0.33 meters. Okay, so let's carry on with the problem now. I'm going to find my moment of inertia. Moment of inertia. I have 2 point masses. So I have my equation for point masses is mr squared. That's m1, and then m2r squared. M1 is 1 kilogram. And the distance, this is the distance from that mass to the center of gravity. So that's 0.67 meters squared. Plus m2, which is 2 kilograms. And then that distance right here is 0.33 meters squared. So I'm going to punch this into my calculator, and I get 0.67 kilograms meters squared. Okay, that's my moment of inertia. Okay, so we're going to continue this problem. We're given the 20 RPM and then the 5 seconds, and we know it needs to stop. So I'm going to take, this is what I'm going to use later. I'm going to erase this, and I'm going to talk about the kinematics of this. So the frequency is 20 RPM, RPM, RPM. And I'm going to convert that to RPS, which is revolutions per second, also known as Hertz. So that's wrong. So this is as if I'm saying, instead of this, I'm going to write revolutions per minute. So 1 minute, 60 seconds. Get rid of the minutes, and I get my frequency, which is 0.33 revolutions per second, also known as Hertz. Okay, I know that omega final needs to be 0 radians per second. I know that I can probably find my initial angular velocity because I have the frequency. So the equation for this is 2 pi over t, or you can rewrite this so you know that frequency is the inverse of period. So you can write 2 pi times f. So 2 pi times 0.33 hertz is going to be my initial, which is 2.07 radians per second. Okay. T is 5 seconds, so I'm going to use this equation to find my angular acceleration. I need my angular acceleration because my goal is to find my torque. I have this number, I found that already. So if I find this, then I have my net torque. Okay. It's important to use this equation and not this equation, because if they're telling you that this thing needs to stop, this equation doesn't imply that. It doesn't imply that this thing is going to stop. So you need to know the acceleration that would stop this rod from rotating. Okay. This equation is like the initial torque that's moving when it starts from rest. Okay, so this is not the equation you want to use for this problem. It's really important to use this equation. Okay, so you're going to solve for acceleration. You'll find acceleration equals negative 0.414 radians per second squared. You're going to plug that into this. You know I already. So your answer will be negative 0.277 Newton meters. Okay, number 63 done. Okay, so I will try to find some center of gravity problems, and I'll make it optional for you to do. For those of you who are taking the AP tests, this is probably a really wise decision to do these problems that I find. I'll look in the textbook for it. Okay. Next problem.